This video is going to be a follow-up to the previous one I did on delta-epsilon proofs. In that video, I looked at limits of linear functions, but in this video, I'm going to look at limits of monomials, specifically of x squared and x cubed. Before I get into those, I'm going to recap the logic that we use in delta-epsilon arguments. We want to show an if-then statement that an if-then statement is true. So the general form is if A, then C. A is called the antecedent and C is called the consequent. The way we show this is by assuming that A is true, and then we show step by step how it follows that C is true. So show C is true, and once you do that, you can conclude that if A, then C. All right, with that being said, let's get started. So the first limit we're going to look at is limit as x goes to 3 of x squared. This is going to be equal to 9. We want to prove this precisely. And we do that by looking at the, by showing the, if. So our antecedent is going to be the variable x, and then minus the number that we're going to, which is 3, less than delta. Then our consequent will be absolute value of the function, which is x squared minus 9 less than epsilon. So our objective here is to figure out what value of delta to choose so that this consequent will follow. The way we do that is by working backwards. We start with the consequent, and we're going to, off to the side here, I'm going to write absolute value x squared minus 9 less than epsilon. I want to write this so that it looks like the antecedent. So I'm going to factor the left side here. So that is x plus 3 times x minus 3. And now I'm going to split up the absolute value sign. So this is absolute value x plus 3 times the absolute value of x minus 3. Now, I want to get rid of this x plus 3 here. So what I do is I say that there is an upper bound, a constant. So as x goes to 3, there's going to be a constant that is the upper bound of this function here. So absolute value x plus 3, absolute value x minus 3, this is going to be less than some constant c times x minus 3, which is less than epsilon. And I can solve now for absolute value x minus 3 less than epsilon over c. I divided both sides by c here. And so one choice of delta is going to be epsilon over c, but we don't know what c is, so we have to consider the set of points on the x-axis that are within a distance a from 3. So that is represented by absolute value of x minus 3 less than a. Our goal now is to solve this inequality for x. So this is negative a less than x minus 3 less than a. We solve for x by adding 3 to all sides. So this is 3 minus a less than x less than 3 plus a. And just to visualize this for you, we have here the x-axis. This is 3, and this is 3 plus a. This is 3 minus a, and these are open circles, and we're considering points in this interval. The point is that we know what the highest value of x is, so we can write a formula for c, the upper bound. So it's going to be the absolute value of x plus 3. The highest value of x is 3 plus a, and so this is plus 3. So c is going to be 6 plus a. So we need both of these conditions to be satisfied, this one as well as this one. So for delta, we can choose either a or epsilon over c. We choose the one that's smaller so that both of these inequalities are satisfied at the same time. So we say we denote that by writing delta equals minimum or min of A and epsilon over c, which is 6 plus a. Now, we need to prove this if-then statement for both values of delta here. So suppose A is smaller. Then I'm going to choose delta equals A. And now that I have my choice of delta, I can prove this if-then statement. So I assume that the antecedent is true. So this is absolute. So assume absolute value of x minus 3 is less than A. And now I'm going to prove the consequence. So I'm going to start with the left side here. That's absolute value of x squared minus 9. I'm going to factor this. So this is x plus 3 times x minus 3. And I'm going to split up the absolute value sign. So this is x plus 3 absolute times the absolute value of x minus 3. And now this is going to be less than the upper bound of x minus of absolute value of x minus 3. That is going to be less than a. That's what we assumed. So this part here is times a. And the upper bound of absolute value of x plus 3, that is going to be c. The highest value that x takes is 3 plus a, and adding it to 3 gives me 6 plus a. So this is going to be less than 6 plus a. Now, a is an arbitrary number that's positive. I can take it to be as small as I want, so much so that it is less than epsilon. So I should write it out. A is arbitrarily small. Oh, whoops, not smaller, just arbitrarily small. Therefore, I can make this right side as small as I want to, including epsilon. X squared minus 9 less than epsilon. This is the consequent, and this part of the proof is done. And now, I suppose that epsilon over 6 plus a is smaller. So then I choose delta equals epsilon over 6 plus a. And now I show this if-then statement again. So I assume the antecedent, which is x minus absolute value of, assume absolute value of x minus 3 is less than delta, which is epsilon over 6 plus a. And I'm going to start off with the left side here. Absolute value of x squared minus 9. This is absolute value of x plus 3 times x minus 3. This is the absolute value of x plus 3 times the absolute value of x minus 3. And this is less than. Now, I assume that the absolute value of x minus 3 is less than this here, epsilon over 6 plus a. And as before, absolute value of x plus 3 is less than c, which we said is 6 plus a. And the 6 plus a's cancel out, and what's left is epsilon. This is the consequent that I wanted to show. So, we have shown the if-then statement to be true for both values of delta. Therefore, this limit is true by the precise definition of a limit. Now, I'm going to show you one more example, the one with x cubed. So, it's pretty much the same process here. So, if you'd like to try this yourself, feel free to pause the video. But I'm gonna show you the process pretty quickly here. So, limit as x goes to 2 of x cubed. We know that this is equal to 8. The goal is to prove the if-then statement. If we have an absolute value of x minus 2 less than delta, then absolute value of the function, which is x cubed minus 8, this is going to be less than epsilon. So as before, we want to find out what to choose for delta, so we work backwards. I'm going to, so off to the side, I'm going to work with the consequent and work backwards. I want to write this so that it looks like the antecedent. So I'm going to factor the left side here. The way we factor a difference of cubes, that's going to be x minus 2 times x squared plus 2x plus 4. This is less than epsilon. I split up the absolute value sign, so this is absolute value of x minus 2 times the absolute value of x squared plus 2x plus 4. And now I'm going to choose a constant c that is bigger than this absolute value here. So absolute value x minus 2, x squared plus 2x plus 4. This is less than x minus 2 times some constant c, which is less than epsilon. And I can solve now for what looks like the antecedent by dividing both sides by c. So of this right inequality here. So absolute value x minus 2 is less than epsilon over c. We don't know what c is. We have to find it by considering the set of points on the x-axis that are within a distance a of 2. We write that like so. Absolute value of x minus 2 is less than some a's, some arbitrary distance a. We want to solve this inequality for x. So we say negative a less than x minus 2 less than a. I solve for x by adding 2 to all sides. So this is 2 minus a less than x less than 2 plus a. And the reason we're doing this is because we know what the highest value of x is. It's 2 plus a. So I can write a formula for c. C is going to be, so if I plug in the highest value of x into this function of x here, this is going to be 2 plus a squared plus 2 times 2 plus a plus 4. And if I simplify this, this is going to be a squared plus, let's see, that is a 6a plus 12. I know what c is, and I need both of these conditions, both of these inequalities to be satisfied. So I need to choose, so the value of delta that I choose has to be the smaller of a and epsilon over c. We say that delta equals the minimum of a and epsilon over a squared plus 6a plus 12. And I have to show this, that this if-then statement is true for both values. Suppose a is smaller, then choose delta equals a, and I'm going to assume that the antecedent is true now. So assume absolute value of x minus 2 is less than delta, which is a. And now I want to show that the consequent is true. How do I do that? By starting with the left side. We have the absolute value of x cubed minus 8. I'm going to factor this. So this is x minus 2 times x squared plus 2x plus 4. And I'm going to split up the absolute value sign now. So this is absolute value x minus 2 times the absolute value of x squared plus 2x plus 4. This is less than. I assume that absolute value of x minus 2 is less than a. So this part here is a. The upper bound of absolute value of x squared plus 2x plus 4, that is c. What is c? C is at a squared plus 6a plus 12. So a squared plus 6a plus 12. Now, a is arbitrarily small, so I can take this right side to be as small as I want to. So a is arbitrarily small. Therefore, absolute value of x cubed minus 8 is less than epsilon. That is my consequent that I wanted to show. We're done with this part. Now, we do the same thing again with this term here. So now suppose epsilon over a squared plus 6a plus 12 is smaller. Then choose delta equals epsilon over a squared plus 6a plus 12. And now I assume the antecedent is true. So assume absolute value of x minus 2 is less than epsilon or is less than delta, which I said is equal to epsilon over a squared plus 6a plus 12. And now I want to show that the consequent is true. So I start with the left side, and this is going to be absolute value x cubed minus 8. Factor it, that's going to be x minus 2 times x squared plus 2x plus 4. Split up the absolute value sign. So this is absolute value x minus 2, absolute value x squared plus 2x plus 4. What is this less than? I assume that the absolute value of x is less than this. So I write epsilon over a squared plus 6a, sorry, that looks like a 2, plus 6a plus 12. And now, what is the upper bound of x squared plus 2x plus 4? That is c, which is a squared plus 6a plus 12. These cancel out, and what's left is epsilon. I have shown that the if-then statement is true for both values of delta, and therefore this limit has been proven using the precise definition of a limit.